Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. All right, lesson 12, properties of logarithms. Okay, classwork opening exercise says use the approximation of log 2 to equal or approximately be 0.3010. So let me highlight that. Highlighter. So the log of 2. We're going to use the approximation of log 2 to approximate the value of these. Okay, so let me switch back to my pen. Let's start with red. And what we're going to do is we're going to rewrite these as logs that have 2 in them. So this is going to equal the log of, and how do I represent 20 using a 2? Well, it's 2 times 10. Okay, or let me put the 10 first, just because. So 20 is 10 times 2. And from our previous lesson, then when we have products here, we know that we add them. Okay, so this is going to equal the log of 10 plus the log of 2. Okay, and if you don't remember, log base 10s are pretty easy to work with, because if I just go and I go in my calculator and say the log of 10, it's going to give me 1. So this is going to equal 1 plus. Now I'm going to use my approximation of 2. The log of 2 is 0.3010. So I'm going to put 0.3010, and that is going to equal 1.3010. And again, I should not use an equal sign. It should now become an approximation. Okay, so there is part A. Now we're going to move to B, and I'll do that over here. So I'm going to do the log of 0.2 equals the log of something times 2. Well, to get a 10th, it is going to be 1/10 of 2 will give me 2/10. So it's going to be 0.1 times 2. 0.1 times 2 is 0.2. Okay, so then this is going to become the log of 0.1 plus, put parentheses around that, the log of 2. Okay, well, the log of 0.1, let's make this an approximation now. As soon as I go from a decimal to a log value, it's going to become an approximation. The log of 0.1, well, if I go to my calculator and say the log of 0.1, well, that is 1/10. That's just moving the decimal place left 1. So it's moving a decimal place left would be a power of -1. So the log of 1/10 is -1 plus the log of 2 approximation is 0.3010. So that is going to be an approximation of negative. And we need to be careful here. Whenever we're subtracting, -1 plus this is going to be -0. And what number here would get me to 1? That'd be 7090. Okay. No, it wouldn't. Hang on. Trying to do this in my head. Think of this as 1.000, or this -1. So taking 0.3010 and subtracting 1, we're going to get a negative number, and plus 0.3010 will become -0.6990. Okay, so if I added these two numbers, not looking at this negative sign, I would get 1. Okay, the next one, the log of 2 to the 4th power. Okay, Well, this kind of comes from the last lesson, if you remember the rule. And so this is going to equal the log of 2. And remember what power of 4 means. It means to multiply that many times the base. So it's 2 times 2 times 2 times 2 is 2 to the 4th power. So with our log rule, it's going to be the log of 2 plus the log of 2 plus the log of 2 plus the log of 2. And the log of 2, it's not equals, it's an approximation. The log of 2 is approximately 0.3010 plus 0.3010 plus 0.3010 plus 0. 1, 2, 3, 4. Okay. So the log of 0.3010. I'll just do 0.3010 times 4. It's the same thing as adding it 4 times. And I get 1.204. And routing to the 10,000th place is 1.2040. Okay, so now exercises. It says for each exercise 1 through 6, explain why each statement below is a property of base 10 logarithms. All right, so pause the video, see if you can do these and come back and see how you did. So for exercises 1 through 6, explain why each statement below is a property of base 10 logarithms. So property number 1 says the log of 1 equals 0. All right, so we're just going to do this. So what we could say is because if a capital L equals the log of x, if that means that 10 to the power of L equals x, okay, so that's what this logarithm means. If L equals the log of x, that means that base 10 with the power of L is going to equal what we're taking the log of over here, which is x. So if x equals 1, 10 to the what power equals 1? Well, that's 10 to the 0. L has to be 0. So if we have a log of any number, log of 1 equals 0 is a property, really important property, because that is our kind of our identity of logarithms. The log of 1 is 0. Property 2 says the log of 10 equals 1. So again, we're just going to keep saying because L equals log of x, that means 10 to the L equals x. Then when x equals, and then what is our x here? Our x is 1. Our 10, I mean, our x is 10, then our L has to be 1. Okay, so that basically what that is saying is this here, because L equals the log of x, means 10 to the L equals x. So we're just going to keep writing that every time. Then when x equals 10, okay, put 10 here. So maybe I should just write this, maybe it's not clear enough. So if I substitute these in, 10 to the L at L equals 0, that's saying 10 to the 0 equals 1 in this problem, and that is true. And in this case, when x equals 10, L has to be 1, and 10 to the first power is 10, okay? Property number 3 states that for all real numbers R, the log of 10 to the R equals R. Okay. So because log of L equals log of x means 10 to the L equals x, like always, then when x equals 10 to the R, this is what we have in place of x. So I'm going to put 10 to the R here. Then L has to equal R, obviously. If the bases are the same, the exponents must also be the same. So L has to equal R. Okay, property number 4. For any x that's positive, 10 to the power of the log of x equals x. Okay, so then we're just going to use the same rule we've been using. Because L equals the log of x means that 10 to the L equals x. then x equals 10 log x. Okay. So think about this one for a second. Because L equals log of x means 10 to the L equals x, then x equals 10 log x. 10 to the power of log x. Okay, how can I explain that? All right, I guess this is just substitution. Right here it says L equals the log of x. So here's L. So instead of an L there, we're going to put the log of x. And therefore 10 to the L equals x, therefore x equals 10 to the log of x. It's just a simple substitution. Okay, number 5 says property 5 for any positive real number x and any y, x and y I should say, for any positive real number x and y, the log of x times y equals the log of x plus the log of y. Hint, use an exponent rule as well as property 4. So what we're going to do is say by the rule a to the power of b times a to the power of c equals a to the power of b plus c. And therefore 10 log to the power of log x times 10 to the power of log y is going to be equal to 10 to the log of x plus the log of y. Okay. Okay, so then we continue. Property 4 says that if we have the log 10 to the power of the log of x times 10 to the power of the log of y, we're going to simply get x times y. Because base 10 log of something is just going to be what we're taking the log of in the power. That's going to be our simplified value. And therefore, x times y equals 10 log x plus 10 log plus log y. Let me re-say that. X times y equals 10 to the power of log of x plus the log of y. Okay, again by property 4, x times y equals 10 to the power of log x times y. Then the log 10 to the power of the log of x times y will equal 10 to the power of log of x plus the log of y. That's this rule up here. So the exponent must be equal, and log of x times y has to equal the log of x plus the log of y. Okay, property 6. For any positive real number x and any real number r, the log of x to the r equals r times the log of x. So what they're basically saying is it's the power rule. We're taking the exponent of what we're taking the log of, and that ends up becoming the coefficient out in front of the log. So it says use an exponent rule as well as property 4. So by the rule a times b to the power of c, that's the power rule, that equals a to the power of b times c. So 10 to the power of k times log of x is going to equal 10 to the log of x to the power of k. Okay, it's a power rule. So by property 4, 10 to the log of x to the power of r, 10 base log x is just going to be what we're taking the log of, which is x, and that's going to be the power of r. Okay, hopefully that makes sense to you. And therefore x to the r equals 10 to the power of r times the log of x. So again, by property 4, x to the power of r equals 10 to the power of log of x to the r. So then 10 to the power of log of x to the r equals 10 times r log x. We're just doing that power rule in the exponent of 10. So the exponent must be equal, and the log of x to the power of r equals r times the log of x. Okay, so that was just kind of like a proof sort of in general. Okay, so now we're going to apply these properties. It says apply the property of logarithms to rewrite the following expressions as a single logarithm or number. So we're taking the rule where the power that was moved out in front actually came from this 1/2 out in front. Okay, I had to fix my pen there, it failed. Okay, so 1/2 times the log of 25. So if we look over here, that would be r log x. Well, where does what's that equal? It's the log of that number, that x, but the r becomes the power. So this 1/2 will get moved up here. So that's the first thing we need to do in this problem. So I just wanted to show that where that's coming from. So this is going to get rewritten as the log of 25 to the power of 1/2 plus the log of 4. Well, taking a power to 1/2, if you remember your algebra, 1, that just means the square root, where your denominator is your radical. So remember the radicals here. The denominator is your index, and your numerator is your radicand, or your power of your radicand. So 25 to the 1 is simply 25, and 2 is the square root of 25. So the 25 to the 1/2 is just the square root of 25, which is 5. So this is going to become the log of 5 plus the log of 4. And by our power rule, when we add logs with the same base, we get the log of that base to the 5 times 4. So this is going to equal the log of 20. Okay, hopefully that made sense to you. So 1/3 the log of 8, well, that would become the log of 8 to the 1/3 plus the log of 16. Well, 1/3, again, that's the cube root. Our denominator, remember, if we have something to the 1/3, the bottom number, the denominator is our index, and the numerator is the power of our radicand. So that's going to be the cubed root of 8, which is 2. 2 times 2 is 4 times 2 is 8. So this is just going to simplify to the log of 2 plus the log of 16. Well, that just tells us that when we're adding, that we take the product of what we're taking the log of. So that's going to be the log of 2 times 16. I'll just show all my work. The log of 2 times 16, which is the log of 32. So 1/3 log 8 plus log 16 equals the log of 32. And I can always check that with my calculator when I'm done. So if I do this, 1/3 the log of 8 plus the log, whoops, not natural log, the log of 4, and I get an answer, then I check the log of 32, they should be equal. Okay, so what did I do wrong here? Let's try that again. 1/3 the log of 8 plus log 16. Enter. That's better. I must have entered it incorrectly last time. And then I do the log of 32, and that comes out to be 1.50514, which these two are equal. And that's how one way you can use your calculator to check your work when you're done. Okay, so this one here, this power is going to go up here. So this is going to become the log of 5 cubed plus the log of 0.8. And I'm going to use my rule here, the log of 0.8. Let me see, how would I want to represent this? Let's just leave that 0.8 for now. So the log of 5 cubed is 125. So this is going to become the log, I should have that in parentheses, by the way, the log of 125, which is 5 cubed, plus the log of 0.8 is going to be the log of 125 times 0.8. So that is the log of, and I take my calculator, 125 times 0.8 is going to give me 100. Okay, so the 3 log 5 plus log 0.8 equals log 100. Okay, number 8 says, apply properties of the logarithm. Rewrite each expression as a sum of terms involving numbers, log of x and log of y, where x and y are positive real numbers. Okay, so what we're going to do here is we're just going to expand this out. This is all multiplication. That's multiplication. That's multiplication. We're going to split it up into different logs. So we're going to apply the log rule, which is log of 3, my first term. And since we're multiplying, we're going to put a plus sign, and then we have to write the word log every time. And now it's going to be x squared. I'm going to do one step at a time here. We're not done. Plus the log of y to the 5th. But then we're going to apply our power rule, and we need to move these exponents out in front. So this is going to simplify. The log of 3 is just simply the log of 3. That did not change. This 2 has to get moved to become the leading coefficient of that term. And so does this 5. So this is going to become 2 times the log of x plus 5 times the log of y. So it's log 3 plus 2 log x plus 5 log y. Okay. Now this one, that's the square root. All right. So remember that taking the square root, if I take the square root of x, that equals x to the 1/2. Okay. We're going to keep that rule over here. Keep that in mind while we're doing b. Let me switch to red. So this is going to become, and I'm going to split this up first. I'm going to do log of the square root of x to the 7th times the square root of y cubed. Okay, I split that up. That's okay. We can do that. And then we're going to take the log, and what does the square root of x mean? It means x to the 1/2. So this is going to be x to the 7 to the 1/2 times, I should have a bracket here or something. And this is going to be y cubed to the 1/2. Okay. And then we do our rule, and we move them out in front, or actually we can do our power rule first. So the log of, let me fix this. X, well, 7 times 1/2 is 7/2 times y to the 3 times 1/2 is 3/2. So that's what we get there. And now I'm going to do the rule where we bring them out in front and add. So this is going to be, well, let's add first. The log of x to the 7/2 plus the log of y to the 3/2. I'm just showing all my work here. And then I'm going to move the exponent out in front. So this is going to become finally 7/2, 7/2 the log of x plus 3/2 log y. Okay, and that's b. Okay, now we're getting into the nuts and bolts of logarithms, and it's really cool how this works. It says in mathematical terminology, in mathematical terminology, logarithms are well defined because if x equals y, then the log of x has to equal the log of y. What you do to one side, you do to the other, just like any other operation, right? If x and y are both positive. This means that if you want to solve an equation involving exponents, you can apply a logarithm to both sides of the equation, just as you can take the square root of both sides when solving a quadratic. You do need to be careful not to take the logarithm of a negative number or 0. Okay, and why is that? Well, let's take a look just real quick. If I turn my calculator on and clear it and I take the log of 0, I get an error domain. It cannot happen. We cannot take the log of 0. Well, what if I take the log of -2? Error, non-real answer. Okay, so we can't take the log of a negative number. All right, so with that in mind, if we're given an equation like this, 10 to the power of 10x equals 100, we want to know what x is. All we have to do is take the log of both sides. So we would do the log of 10 to the power of 10x equals the log of 100. Okay, and with our rule here, 10x is going to come out in front. Okay, actually not even that. Remembering our previous rule, if we take the log of a base 10, what we end up with is the exponent by itself. Then we did that on the previous page. That's just going to become 10x. So 10x equals, and the log of 100 is the same as saying 10 squared, the power is 2. And let me write that just so you see where that's coming from. So the log of 100 can be represented as 10 squared. So if I take the log of 10 to a power, the power is the answer. If I take the log of 10 to a power, the power is the answer. So that's going to be 10x equals 2. Divide both sides by 10, and I get x equals 2/10 or 1/5. Okay, so there's A. B, again, we're going to take the log of both sides. So the log, I just clicked on green, it didn't work. There we go. The log of 10 to the power of x minus 1 equals the log of 1 over 10 to the x plus 1. Okay, this one's a little bit different. We need to take an exponent rule and get rid of this fraction. So before I even write this, there's no need to do that. Let me just change this. Okay, remember our rules. If we have something to the negative, then it gets the reciprocal. Okay, so in other words, 2 to the -2 equals 1 over 2 squared. Okay, so if I want to get rid of a fraction, I just flip it over and make the power negative. So if I flip this over and make the power negative, let me just do that first without even doing the log first, just in case this is confusing you. Let's just leave 10 to the power of x minus 1 on the left. And I'm going to take the reciprocal of this, which is 10 to the power of x plus 1. Okay, but that's going to be to the power of -1 because I flipped it. So now I'm going to take the log of both sides. So that's going to be the log of 10 to the x minus 1 equals, and that power rule brings us negative out front. -1 times the log is just the negative log of 10 to the x plus 1. Okay, really cool how this works. So log base 10 of any power, the answer is that power. So I get x minus 1. Log of 10 to any power is that power. So I'm going to, that negative sign stays here, but it's going to be this x plus 1 that we're taking the negative of, and make sure you put parentheses around it because we need to distribute. Okay, so now we're going to continue this. So we get x minus 1 equals negative x minus 1, right? Distributing that negative. Add x to both sides, and I get 2x. Add 1 over to here, we get 0. So x equals 0. All right. Part C. 100 to the 2x equals 10 to the 3x minus 1. Well, on this one, I'm going to rewrite this as I'm going to do this a little differently. I'm going to rewrite this as 10 squared to the power of 2x equals 10 to the 3x minus 1. Then I'm going to do my log of both sides, the log of 10 to the 2 to the 2x equals the log of 10 to the 3x minus 1. This 2x is going to go out in front, so I get 2x log 10 squared equals log to the 3x minus 1. Okay. All right, so this is just 100, by the way. So let me change that. No sense in doing a power rule again. We have a number to a power, it's just 100. So I have 2x log 100 equals log 3x minus 1. And I'm going to bring that next rule in. 2x log 100 is going to be, actually, I should have just left it. Let me just make that 10 squared. I should show that. And then this 2's got to go out in front. Well, 2 times 2x is 4x log 10, right? This was 10 squared. The 2 goes out in front. 2 times 2x is 4x. So it's 4x log 10 equals 3x. Oh, what did I do wrong here? Log 10 to the 3x minus 1 log, I forgot my 10 here. I might be writing too much stuff here and confusing you because the log base 10 goes away. We're just going to get 3x minus 1. So we have 2x log 100 equals 3x minus 1, which would be 4x log 10, but the log of 10 is 1, remember? So if I get my calculator, the log of 10 is 1. Okay, so this is just 4x times 1, or simply 4x equals 3x minus 1. Subtract 3x from both sides, and I get x equals negative 1. Okie dokie. All right, number 10. Solve the following equations. So we have 10 to the power of x equals 2 to the 7th. We have an exponential equal to a value that we know, 2 to the 7th power. Now don't go and say 2 times 2 is 4 times 2 is 8, 16, 32, 64, 128. Do not change 2 to the 7th to 128. Leave it 2 to the 7th, and we're going to take the log of both sides. So the log of 10 to the power of x equals the log of 2 to the 7th power. Okay, I suppose I should put parentheses around what I'm taking the log of, and then my power goes out in front. Actually, in this case, log of 10 is just simply 1. So x times 1 is x, and that's what really happens there. And this is going to become 7 log 2. Okay. I could continue that and put it in my calculator now and get the actual value, and I will do that. 7 log 2, enter, is 2.1072097. So what that really means is, think about this. We now know what the power of 10 is that would give us 2 to the 7th, which is 128. So if I now store my answer as x, okay, there it is. And I take 10 to the power of x, then I should get 128. And look at that. Okay, so that's really what logarithms do. They solve exponential equations. So 10 to the x squared plus 1 equals 15. So I'm going to take the log of both sides. Log of 10 to the x squared plus 1 equals the log of 15. Okay, take my rule here, and that's just going to be x squared plus 1 equals the log of 15. Okay, and then I'm going to subtract 1 from both sides. Okay, I'm just going to keep working down, then I'll move this. So I'm going to subtract 1 from both sides. That will give me x squared equals the log of 15 minus 1. And then to get x by itself, I'm going to take the square root of both sides. And that is going to give me x equals plus or minus the square root of log 15 minus 1. And be careful with that. Take the log of 15, then subtract 1 from your answer. Do not take the log of 14. So then when I get this, I could simplify this or find the value of this. So I could take the square root of the log of 15 minus 1 and get this number right here. So if I plug that into and I store that as x, I'm just checking my work here, store it as x. Now I want to go back up and put in 10x squared plus 1, and I should get 15. So if I put in 10 to the power of x squared plus 1, I should get 15. And there it is. Okay, it checks. I won't check the negative side. It would be the same. All right, so let's move on to this one. I'll do it in a different color so I don't have to move it. Extend the page for a little more room. And what we're going to do is we're going to take the log of 4 to the x equals the log of 5 cubed. Do our power rule. X log 4 equals 3 log 5. Okay. Now to get x by itself, we're going to divide both sides by the log of 4. Okay, so the log of 4 cancels here, the log of 4 cancels here, thus leaving with x equals 3 log 5 divided by log 4. Okay, I suppose I shouldn't get lazy here. I should keep writing these in parentheses. There we go. Okay. All right, so x equals 3 log 5 divided by log 4. So again, you want to know if you're right. How do you know if you're right? Well, go 3 log 5, enter, divide by the log of 4, enter, store it for a variable x, enter. So 3.482892142 is an approximation of this. Now I want to see if 4 to the power of x equals 5 cubed, which is 125. So now if I go 4 to the power of the x that we just stored, I should get 125. If I do, I did this correctly. If I don't, I didn't. Check your work. Okay, that is the end of lesson 12. Review the lesson summary and go to your problem set.